So here we go. Okay, I need you paying attention. Get your note sheets out. We're going to do a little graphing. And the information that you're going to have in your graph, so we're all looking at the first problem, right? Everybody's looking at problem number A.
7A?
We're on 2.6, which is on the back of page 19.
Oh, yep, I got you.
Back of page 19, 2.6. We are going to sketch this. Now, the information that's going into the graph, we're going to have vertical asymptotes, we're going to have horizontal asymptotes, and I'm not going to write this down every single time, but I thought for this first one, we'd go through, maybe take some notes somewhere, maybe clear down at the bottom or something of the page, or on another sheet of paper. We're going to have holes, we're going to have our Y-intercept, and we're going to have our X-Intercepts. All right? All right, so here we go. Tell me what you remember, because some of this we have already talked about. Tell me what you remember. Somebody remembers something. Okay, who said that? Okay, Austin, you're right. In order for there to be a hole, you have to be able in your problem to do some factoring and then cancel something out. Do you remember that? Can you cancel anything in this problem? No. So this problem is not going to have any holes. I'm going to be graphing it. There are not going to be any holes in it. But let's take a note. Holes come from factoring and canceling. And that's the key. The key right there is canceling. If you can't cancel, you are not going to have any holes. Okay, everybody got it? All right, tell me something else you remember.
The X over X, I think that's the horizontal.
Exactly. You put X over X, or if you had X squareds, it would be X squared over X squared. You put the highest powers over each other, and that is your horizontal asymptote. So your horizontal asymptote is Y equals X over X. I don't know how else to write it. Remember what we talked about though? We could have X squared over 3X squared, it would be this. That's how you find your horizontal asymptote. So in this problem, what is my horizontal asymptote? 1. So I have a horizontal asymptote at Y equals 1. Notice it's Y equals. Your horizontal asymptote is Y equals. All right, anybody remember anything else? Oh, your vertical asymptote you should remember. Vertical asymptote, whatever makes the denominator 0. So X equals whatever makes denominator 0. So, what makes my denominator 0? 3. So I have a vertical asymptote at X equals 3. Okay? Now, intercepts. If I am an X-intercept, that means I'm on the X-axis, right? What can you tell me about any point on the X-axis? What do all these points have in common? Think about their ordered pairs. What do they all have in common? There's something, comma, 0. So X-intercepts we're going to, there's something, comma, 0, so we're gonna let y equal 0. In order to find an x-intercept, we're gonna let y equal 0. So for my problem, I'm going to have 0 equals x plus 2 over x minus 3. Right? Now to solve that, I'm going to multiply this over to here. Now what's going to happen? Since that's a 0, what's going to happen when I bring that over? Now be careful, I'm multiplying this over to here. It's still 0. So basically the denominator disappears, doesn't it? Because when I multiply by 0, it's still just 0. So x is going to end up equaling -2. So basically what I did was I ended up solving the numerator. So I let y be 0, but what I really end up doing is solving the numerator. Because the denominator is always going to disappear, because you're always going to have a 0 here. So you end up solving the numerator. I get -2. Now, how do I get a y-intercept? Let x be 0. So a y-intercept, we're going to let x be 0, and that's real easy. If you put in zeros for x, what do you end up with? 2 over -3, -2/3. So you've got your vertical asymptote, your horizontal asymptote, your x-intercept, your y-intercept. Now you're ready to graph. Okay? Now I want you to think back for a minute to your BFFs. You haven't thought about your BFFs in a long time. Were there any BFFs that had a horizontal and a vertical asymptote in them? I'll give you a hint, yeah, there was one. Which was the one that had a vertical and horizontal asymptote in it? Oh, you people have no excuse. You're not old, you haven't had chemo. How can you forget your BFFs?
Wait, it has both of them?
Yep, it has a vertical and horizontal in it. It's the reciprocal function.
Yep.
The reciprocal function has asymptotes here and here and looks like this, remember?
Yeah.
This is a version of the reciprocal function. Now, the asymptotes are moved and all that, but it's okay. This is how, oops, these have to be connected. This is how this picture looks. So there's a piece of it down here, because these two dots have to be connected. So there's a piece of it right there. Any idea where the other piece is?
Where do those two meet?
Right up here. It's just like the reciprocal function. It has these things opposite each other. The asymptotes are moved. They're not in the same place as your basic reciprocal function. But that's a fraction. Remember, the reciprocal function is a fraction, a very simple fraction, but it's a fraction. We've made the fraction a little more complicated. That moves some things around, but it's still that same basic shape. What, Joseph?
Oh, no.
Okay, all right, you pay attention and let them do whatever they're doing, which they shouldn't be doing, whatever it is.
No, I was tapping the wall.
All right, let's try the next one. Let's see how you do with the next one. All right, I'm going to leave those notes there for one more problem, and then I'm going to get rid of it. We'll leave them there for this next problem. We'll graph another one. Here we go. It is x minus 2 over 1 minus x. All right, so let's fill in what we can. Tell me anything you can see about this graph. All that stuff right there. What can you tell me about it?
X is positive.
The vertical asymptote is where x is positive 1. Now, how does she know that? Where do vertical asymptotes come from? What makes the denominator 0? What number would make that 0? 1. That's why she put it at 1. All right, what else can you tell me? Maddie? It is -1 because look here, kids. When you build your horizontal asymptote, you get x over -x, which is y equals -1. Perfect. All right, what else can you tell me? There's no holes, because the only way you're going to get a hole is if you can factor and cancel. Nothing cancels in that problem. Don't even think about it. Nothing cancels. If you cannot factor, you cannot cancel. Okay? All right. Okay, what else?
The Y-intercept is 0, 2.
Y-intercept is 0, 2. Now, how did she get that, people? She let x be 0. So she got 0 minus 2 over 1 minus 0. What does that equal? -2. So my y-intercept is at -2. Doesn't that equal -2? Okay. And how about an x-intercept? How do I get an x-intercept? I put 0 in for y, which essentially means I solve the numerator. So if you solve the numerator, what do you get? 2. Now this is another variation of the reciprocal function. Can you visualize it? Look at where your dots are. Look at where your asymptotes are. What do you think it looks like? Just like the last one. Yep, just like the last one. You okay? All right, now I'm going to erase all of this. Hopefully you've written that down, taking good notes, because that's the stuff we need to find every time. But this next problem's a little bit bigger. Yep.
Why was the y-intercept 0 negative? Why wasn't it 0 -2?
It was 0 -2.
Oh, okay.
Yeah. I had it plotted right down here.
Okay.
Yeah. Okay, look at this next one. He's a doozy. Okay, what do you think we need to do with this guy? We need to factor. Now, we're going to be factoring, so there's a chance we'll have a hole, right? How's it factor? Oh shoot, we can factor, but nothing cancels. Okay, that means no holes, no big deal. But, look, there's 2 things down here in the denominator. What does that mean? 2 vertical asymptotes. So I'm going to have a vertical asymptote at -3. X equals -3. And I'm going to have a vertical asymptote at x equals +3. Right? All right, tell me what else I have. I have a horizontal asymptote. Where is it? positive 1. And the horizontal asymptote is at positive 1 because I have x squared over x squared. All right, can you see anything else I have? Oh, Hannah, it's not that bad. You don't have to hold your head. It's not that bad. What else do I have?
What you got?
I gotta let x equal 0. All right. Now you can let x equal 0 here or here, whichever you prefer. Might be easier here. If you put in zeros, you have negative 4 over negative 9, which is 4 9ths. So I have a y-intercept at 0, 4 9ths. Now some of you are just sitting there letting me do all the work, and that's all hunky-dory, except when it comes to quiz time. Maybe you better practice it on your own. To find a y-intercept, we let x be 0. So we put in 0 for the x's and see what we come up with. Now, how do we find our x-intercepts? We let y be 0. And what happens when you let y be 0? The denominator disappears and you end up solving the numerator. So solve that numerator. What do we get? X equals negative 2 or x equals positive 2. So I'm going to have 2 intercepts. One's at negative 2 and one's at positive 2. One more time. To find x-intercepts, we let y be 0. But when we multiply the denominator over to 0, it stays 0 and disappears. So basically, to find your x-intercepts, you are solving the numerator. So the numerator would be negative 2 and positive 2. And there are no holes, we already said that. So this is it. This is our picture. Any thoughts on what it looks like? Because now you need to draw something in. Any thoughts on what it looks like? I have a parabola-like shape here. I agree with you. Got some kind of parabola-like shape right there. But that is only, believe it or not, 1/3 of the picture. There's a chunk of it on that side and there's a chunk of it on this side that you don't have graphed. Any ideas about that?
Oh, is it the
thing? This is even a bigger variation of the reciprocal function. Looks like this. Is this kind of what you thought it might look like? Now, some of you are saying, oh my gosh, Mrs. Ford, how did you know that? Well, I have this huge advantage. It's called being 57 and having done this for 36 years, right? That's my huge advantage. However, you could figure it out, and there are a couple of ways to figure it out. One is logically. All right, so logically, here are my two choices. I know I've got a picture over here somewhere. There has to be something between the asymptotes to the right and to the left. Okay, there has to be. So I know there's something out here, but I don't have any points, so I don't know what it looks like. I do know, though, that as the picture heads off the page, whether it's going right, up, down, or left, as it goes off the page, it's going to get closer to its asymptotes. All right? It's never going to shoot off like that. As it goes off the page, it's going to get closer to the asymptotes. Well, just that fact alone means it either looks like that or it looks like this. Those are the only two options, because as it goes off the page, it's going to get closer to its asymptotes. How do I know it's the purple one and not the red one? Well, if it were the red one, what happens right here? What do I call that point right there? A 0, an X-intercept. And you already told me that the only two X-intercepts are here. So it won't cross anywhere else. It can't. These are the only places it can cross. So if purple and red are my only options, but it can't be red because it can't cross the axis, it must be purple. And we have the same argument on this side. Some of you are thinking, oh, Miss Ford, I don't get it. That's too much for me. Then I want you to set up a T-chart, and I want you to plot some points. Now, which points would you plot? Well, they'd have to be bigger than 3. So maybe you would plot 4, 5, and 6. And 7, 8, 9 if you need to. You plot as many points as it takes for you to figure out what shape it is. And over here, same thing. Only you want less than -3, so you maybe do -4, -5, -6. Now, the lazy ones among you are not going to want to do that because it takes time. But if you truly don't know what it looks like, that's how you tell. You plot points. Now, hopefully, we'll practice enough that you won't have to plot too much. You'll get confident. Let's try the next one. D. Alrighty? So tell me what you know about this guy. It can factor. Alright, so we're going to factor it. Alright, so the top factors have x minus 5, x plus 1. And the bottom, I can take a 2 out of the bottom. So it would be 2x minus 2x plus 2. Joseph, sit up, open your eyes. Are you all right? Any of this down?
I don't know what paper it is.
Well, get out a regular sheet of paper, and you can. I'm putting all the problems up here. You can just write them down on a regular piece of paper. All right, tell me about it. What do I have? Give me some information here, some stuff to put on my graph. What am I going to put in there?
X-Intercept
The Y-Intercept at 0,58. So let me double check that. It sounds good. Let me see. 0,58. So I'm going to go back to the original problem. If I put in zeros, I get 5/8. Yes, indeed. Remember, your Y-intercept happens where you let x equal 0. All right, what else do I have? X-intercepts? There's 2 of them. The X-intercepts are 5 and -1. Very good. Remember, X-intercepts technically happen where you let y be 0, but effectively what always happens is you end up solving the numerator. So 5 and -1. Those are my X-intercepts. All right, what else do I have? Horizontal asymptote.
Yeah.
Where? 1/2. We have a horizontal asymptote at 1/2, which is less than 5/8, so it's just under that dot I put in there. Here's my horizontal asymptote. All right, one more thing to get in there. What about those vertical asymptotes? We have 2 of them. Where are they? 2 and -2. Where do I get vertical asymptotes from?
Where x makes the denominator 0.
Whatever makes the denominator 0, right. So in this case, there are 2 things that make the denominator 0, +2 and -2. Now, as soon as you get all that in there, there's no holes. We got our intercepts plotted. We have our asymptotes plotted. Now it's time for you to draw a picture. So, is there any part of that picture that you feel confident you know what it looks like? There's a part to the left, there's a part in the middle of the asymptotes, and there's a part to the right. Remember, as it goes off the page, it gets closer to an asymptote. So what's your thought? Do you have a thought? See that dot right there? That's a huge clue. That's going to be right down here, just like this. Now, I don't have any dots over here on this side. So my two choices are this and this. Tell me which one it is. Is it the top one or the bottom one? It's gotta be the top. Why does it have to be the top? You can't cross the x-axis. So it cannot be that one. It has to be this one. Perfect. Now what about the middle? You're in between these two asymptotes. What's happening in there? It looks like a cubing function. What is bothering you about that, Quincy? Because you are exactly right. It looks exactly like a cubing function. Why does that bother you? Or doesn't it bother you?
I don't know. It doesn't really bother me.
Okay, I thought it bothered you.
I don't like it.
Does it bother anybody?
Because
Because
it crosses.
it does what?
It crosses the X.
It crosses, well, it's allowed to cross the x-axis because I have a dot there.
Crosses the whole line.
But it crosses the horizontal asymptote. And does that make you feel just a little bit uneasy? No, be okay with it. It's okay to cross a horizontal asymptote. You will never cross a vertical one, okay? Now, I'm going to say that again. You can cross a horizontal. In fact, some of the funkier curves will come out and like oscillate over their asymptote. This one does not. Don't worry about it. If you cross your horizontal asymptote, it's fine. It's very common, especially in the middle of the picture. You will never, ever, ever touch a vertical. Okay? All right, next. Uh-oh, this one looks a little different. I'm going to go ahead and factor as I copy it down. That would be x minus 3 plus 1. Is that right?
Yeah.
Okay. Now, what's a little bit different about this guy? Do you notice anything? Well, let's just start filling stuff in. I think you'll figure it out when we get to it here. What do you know?
Denominator factor.
What's some stuff we know? Yeah, Raven? I have 2 vertical asymptotes. One of them's at 3, x equals 3, and one of them is at x equals negative 1. Very good, Raven. That is exactly right. All right, what else do we know? There are no holes. Nothing cancels. We're going to get some hopefully soon, but right now, no holes still. Maddie?
Does it matter that the X in the denominator is bigger?
Oh, does it matter that the x in the denominator is a higher power than the x in the numerator? Yeah, it matters. What does that tell me about my horizontal asymptote when the power on the bottom is bigger? It's 0. Your horizontal asymptote is y equals 0. Groupies, remember, when the power on the the bottom is bigger. It means the fraction is bottom heavy. You're getting smaller and smaller and smaller. 1/3, 1/4, 1/5, 1/6. It's getting smaller, smaller, smaller. 0. When the power on the bottom is bigger, your asymptotes y equals 0. Paul?
The point on the x-axis is -5.
Yep, that we call that the X-Intercept. Your X-Intercept is -5, 0. Paul got that by solving the numerator. All right, I need one more thing. What's my Y-Intercept?
0, 5/3.
If I put in 0, is it -5/3? I think I get -5/3 if I put it in 0. This is a hard problem. I have absolutely no idea, truly, what this looks like. So what I'm going to do is what you do when you have no idea what it looks like. We're going to plot a couple points. Now, it's not going to take me too many, but it's going to take me a couple. So I'm going to go ahead and plot this point right here. I'm going to plot -2. I'm going to see what happens if I let x be -2. So I'm going to put it in. If I let x be -2, I have 3 over, okay, -2 would be -5 times -1, 3/5. So I'm going to plot the point -2, 3/5. Does that help me figure out what this side of my picture looks like? Remember, these have to be connected, right? So I'm thinking it looks like this. Now, here's where it gets a little tricky. You're tempted to just keep right on going down, right? But what did Mrs. Ford tell you? As you head off the page, you're going to be getting closer to your asymptote, not farther away. Here's the asymptote. All right, I'm going to be getting closer to it, not farther away from it. So what is this thing going to do? It comes down here just like that, but then what does it do? At some point, it comes back up and starts approaching the asymptote. Tricky. Very tricky, but it can't keep going down. It has to approach its asymptote. Now what about in the middle? Do you have any idea what's going on in the middle here? We've had a couple of these already. One was a parabola, and one was a cubing function, right? Do you have any sense of which one this is? Well, if it were a cubing function, what would have to happen right here? I'd have to have a point, and I don't have one. So therefore, it has to be some kind of a parabola. It can't cross the x-axis except here. Now what's going on out there? No idea. It could look like this or it could look like this. Would you agree? How in the world am I going to figure out which way it is? Plot a point. What point am I going to plot? 4. Let's see what happens here. Is it up here or is it down here? Let's see. If I put 4 in, I get 9 over 1 times 5. I get a positive number. So that means this is my shape. freakish problem.
It's honors level.
Honors level, yep. But we are smart, so we can do it. Alright, let's get one more now. I can't remember what time everything is here.
5.
Alright, so one more. Let's get it. Let's see what happens here. We'll do F. Alright, so how are you going to start F? You're going to start by factoring it. We're going to factor F. Top factors how? -4 plus 1. And the bottom is +1. Oh, here we go. Finally, finally, finally. Why am I so excited? I have a hole in my picture. And where will that hole be? Where x equals -1. The hole goes at the x value that you canceled out. So you canceled out an x plus 1. So where would that dot go? X plus 1, the dot goes at -1. That's where the hole is. Now, I rewrote my problem. This is my new problem now, right? To find my y-coordinate of my hole, I'm going to take that -1 and I'm going to put it in right here. Don't go back to the original, go right here. So I put in -1, and what am I going to get? -5 over -2, 5/2. I put in -1, -1 minus 4, -1 minus 1. So I have a hole at -1, 5/2. Alrighty? Now tell me what else I have. Look right here. Do not look back at the original. Look right here inside the box. What else do I have?
Your y-intercept is 0, 4.
I have a y-intercept at 4. And she got that by letting x be 0. So she put in 0. She had -4 over -1, which is 4. Alright, what else do I have?
X-intercept of -4.
Actually, my x-intercept's at +4 also. I have an x-intercept at +4. My x-intercept comes from letting y be 0, but effectively I just solved the numerator.
Horizontal asymptote 1.
Horizontal asymptote's 1 because we've got x over x. Don't be confused. In the beginning we had x squared over x squared. Now we have x over x. Same thing. It'll always be the same. Don't worry. And do I have a vertical asymptote? Y equals, or x, excuse me, x equals 1. Vertical asymptote, x equals 1. Now, believe it or not, even though this problem has a hole, it is way easier than the last one. I think you can tell exactly what it looks like. What do you think? What do you think's going on over here on the left side of my asymptote? Yep, Maddie's got it. She's drawn this in the air. She's got it. That curve has to connect the hole and that dot. So when you just connect those, can you see the shape coming out of that? Connecting these two dots that you have?
Yeah.
The curve is going to go through the hole. I like skip over it, but you know what I mean. That's part of the curve. Now you still have a dot down here. What do you think that part of the picture is going to look like? You've done enough of these, you know it's going to look just like that, right? And you're right. But if you ever have a doubt, set up a T-chart and plot a couple of points so that you have a couple more points to connect. Then you'll know what it looks like. Okay? Alright, so we got to F. We have one more to do. We'll be having a little quiz over that. Not the next time we meet, but probably the time after that, okay? Thank you.